All right, good morning, class. Today we're going to finish up our notes on wave interactions with part 2. And the first topic is diffraction. So diffraction is when an energy wave is moving toward a medium that it cannot travel through, but it can bend around it, or if there's openings in the medium, it can go through it. An example is down here in this diagram right here. We have water waves flowing, and we have two pieces of land. The water is flowing in between the land, which would represent the barrier medium, and in doing so, you can see that the water waves are bending and spreading out after going through the opening in the barrier. So I'm going to take you right here to an online example to help you understand this next relationship. Diffraction of an energy wave will increase, so there will be more bending and spreading out if the gap gets smaller. So we're going to look at how that happens online real quick. Here, you can use this to kind of study, is if we make this gap smaller, notice how that affects the bending and spreading out of energy waves. So we have a whole lot more bending going on and spreading out of the energy. But if we make the gap larger, the bending and spreading out of the energy wave really doesn't occur quite as much. And you can see that the energy is not covering quite as much ground over here as the gap is larger, but when it's smaller, it's spreading out and hitting all of those areas. All right. So the next thing is we're going to talk about another example of diffraction, and that is sound waves. You probably noticed before when you're walking down the school hallways that sometimes you can hear students that are walking in a hallway perpendicular to the one that you're walking in, but you can't see them yet. And that is simply that sound waves are bending around the corner of the walls as they're coming towards you. So if you're walking this way and they're coming this way and there's a corner right here, the sound waves are bending or diffracting around that corner. So that's another real life example. I want you to make sure that you draw a diagram of diffraction. So I'm going to do that with you now just so you can kind of label and make sure you have everything. Alright, so just making sure that we understand diffraction. Here, if we have a barrier medium, we have water waves coming towards it. What might happen is that the water will bend and spread out around the barrier medium. Okay. If we have a medium that has holes in it, and we have energy waves that are flowing towards it, what's going to happen is they're going to flow through, and it causes them to kind of spread out and bend. So we're going to travel through, spread out, and bend. Again, the smaller that the gap gets, the more bending and spreading out of the energy wave takes place. So these are just two instances. Again, if you were a student who was traveling down a hallway, and there's another hallway that kind of intersected here, then you might hear your friend walking this way, talking to other people in the hallway before you see them, and that is simply because the energy is not only going to travel straight forward down the hallway, but it's also going to diffract around the corner, and that is how you are able to hear them with your own ears. Now, before we go on to the next and last wave interaction that we're going to talk about this year, I want to make sure that on the diagrams that you just draw, that you label where the barrier medium is and the gaps, and you could even label the one with the hallways representing how sound energy, and the other one, the other two that we drew first, water waves moving around or in between barriers. So just make sure that you fully understand it before we move on. All right, next thing, interference. Interference is when an energy wave's amplitude changes because one wave comes into contact with another energy wave. And this really happens all the time. I'm sure you've heard of the word interference, and that this is what it is talking about. So there are two types of interference, and there's destructive and there's constructive. So first, let's talk about destructive. Destructive interference is when waves combine in a certain way, in which we're going to talk about in just a second, where the effect is a smaller amplitude. Now, if you remember from our first set of notes, amplitude signifies how much energy the wave is transferring. So if two waves come together and create a smaller amplitude, then the energy carried with that wave is going to be less. So let's talk about destructive interference here with using this diagram right here. So we have wave 1 and we have wave 2, and both of them are coming into contact with each other, and so they may combine into one wave. And what's happening is the way they're combining, we have a trough and a crest that come into contact at the same time. Now, because these waves are identical, they're just not lined up exactly where a crest is lined up with a crest. What happens is you get actually a wave that's not carrying any energy, and the medium is sitting at rest because those two waves completely disrupted the energy that was flowing through it. Now, what's important to understand is for every time two waves combine and destructive interference happens, it doesn't mean that the energy will come to a halt and that won't flow. These just happen to be two identical waves, but if they were not identical and you had a trough line up with a crest, then there would be less energy flow when the two waves combined, but it may not be no energy flow. Going back and looking at the opposite type of interference, we're now talking about constructive. Constructive interference happens when the crest of one wave lines up with the crest of another. And you will see that there is more energy flow with the combination of these two waves, so the amplitude will increase. The diagram here shows something similar from this diagram, but if you notice, now we have crest lining up with crest, trough with trough. And so when these two waves come together, now we have an amplitude that is almost double what the amplitude here is. And so that would be constructive interference. Now again, these two waves are identical, so rarely would you have two identical energy waves combining to create exactly double amount of the amplitude, but this is one example of constructive interference. Moving on, we're going to talk about something that's kind of interesting, and we will do some experiments and demos in class with this topic. But the topic is standing waves. So what a standing wave is when you have a barrier medium and you have an energy wave coming directly perpendicular 90-degree angle into the barrier medium. And what's going to happen is if it can't travel through that medium, or some of it can't travel through that medium, some of the energy will be bounced right back in the same direction. So it'll be flowing basically over itself as it's disturbing the matter. And so what happens is the matter that it's disturbing almost appears to be standing still, even though it's being vibrated back and forth. And sometimes the amplitude of the standing wave can increase and sometimes it can decrease. It just depends on how it exactly bounces off back onto itself. And where it matches up with the crest, or if the crest matches up with the trough, etc. But to me, if you know what double Dutch jump rope is, where you have two jump ropes and you're going, so one's low and one's high at the same time, this is kind of what a standing wave looks like to me. And I want you to kind of think about what type of interaction or what types of interaction would this be. If you're paying attention up here, it does say that part of it has to do with reflection. But since the wave is bouncing back onto itself, it also has to do with interference. So it's kind of both reflection and interference. All right, so I am going to draw a diagram of a standing wave, and I know you have some already on your paper that you could draw on top of, but it might just be easier to start your own diagram. So here I have drawn a force, and so I'm just going to kind of say that some kind of force has created a push or some kind of effect over on the side, and it's going to start a vibration of matter. I'm going to include a rest line, okay? And then I'm also going to show that the wave is transversely propagating through the matter, but then it gets to a point where it hits a medium that it cannot go through. So we're going to call this the barrier medium, okay? And so we've got this rest line, which, by the way, my diagram isn't the best, but I think you can get the picture. And then so what happens is this wave was flowing, but it hits the barrier medium. It can't travel any further in that direction, so it bounces back, and it ends up making a pretty cool design. But this is how it flows back. So the energy now is traveling in this direction. And so this is what a standing wave would look like if you drew a diagram of it on paper. You have a force, you have the initial wave moving in one direction, hitting a barrier medium, and then traveling back on itself. Now, there's some vocab that I want to talk about with you, and it has to do with the position where the wave is basically crossing over itself, and then the position of the high and low amplitudes, both at the same point on the standing wave. So going back to the notes, we have two diagrams, and they're both standing waves. One's just showing over a shorter period of time, one's showing over a longer period of time. And so here, if you look, all of the areas where the energy wave is basically crossing over the rest line, so it's not moving matter from its resting position, that is called a node, which is the non-moving part of the medium, and it's located on the rest. But then you have areas where the medium, there is a low point of movement of the medium and also a high point at the same place, and that is the antinode. So it is defined as the moving part of the medium, and that would be where the positive and negative amplitudes are. And positive and negative just means positive above the rest line, negative below the rest line. So hopefully you understand standing waves a little bit. We're going to do, again, some stuff in class with all of these interactions, and that way you'll get a better feel about reflection, refraction, diffraction, and interference, which includes standing waves. Have a good day.